please input your questions in the chat, indicating your name and affiliation and who the question is for. So then my colleagues will select a few of the questions that we can ask the speakers, and also we'll try to address all the questions post-meeting and circulate the answers with all of you. So just a couple of minutes on every one of our guest speakers for the session today. Our first keynote lecture will be given by Dr. Dimitris Segevnos. The focus will be on the technical and economic drivers regarding brine management, as I have mentioned before. Dimitris is an assistant professor in circular value chains and sustainability at the Technical University of Delft. He has a strong interdisciplinary engineering background with a PhD in chemical engineering and postdoc in civil engineering. Our next speaker for the second keynote lecture would be Mr. Loïc Carpenter. He will provide a talk on the European perspective on brine. Loïc is the manager of the advocacy program of Europe, the European Association of the Innovative Water Sector. He also contributes to the communication of European research and innovation projects on behalf of Water Europe to the European institutions and manages the MEP Water Group Secretariat. Thank you, Loïc. And our final talk today will be given by Dr. Feliu Sempere-Nager. He is a chemical engineer from the Universitat de Valencia in Spain, and he holds a PhD degree on development of a marketable biotechnology for the elimination of solvents in air emissions. So all of them are going to provide us with very interesting talks on brines. So without further ado, I will stop sharing my screen and we will proceed with the first talk of the day given by Dimitris. So Dimitris, please, if you could put your slides on the screen.
Of course.
Please.
I will just start sharing my screen. Give me a second. I hope you can see my screen, Blanca.
Yes, so it is uploading now. Very clear and in full screen mode already. So thank
Excellent.
You.
So then I'm starting then. Thank you very, very much for this kind introduction and for the invitation to join your webinar. As Blanca said, I'm Dimitris Xevianos. I'm an assistant professor at TU Delft, and I will be speaking about technical and economic drivers regarding brine management. So my next slide is not that important anymore because Blanca gave this introduction for me. My background is said from the National Technical University of Athens, mechanical, electrical, and chemical engineer. Maybe something that was important is that I moved to the private sector and I was in the startup community. And then I joined TU Delft in 2017. And since January 2023, I'm an assistant professor there. Now, just for my PhD in chemical engineering, one slide about that, it was in the intersection about within process design, circular economy, and renewable energy. And the title was Creating Value Out of Seawater Desalination Brine. So it had to do exactly with brines through the recovery of water and salts using renewable energy sources. And in the follow-up activities that we'll see also in the next slides, it was also the value for whom and responsibility by whom. And I have been doing a lot of research with the actors. And here is just a picture now of the system for the brines treatment that I had designed and developed within my PhD with a capacity of 2 cubic meters per day. So moving now to the outline of this presentation, I start with where do brines originate from and what can be recovered, what are the different technical approaches to brine valorization, and finally, what are the economic drivers for the brine valorization. Started with the origination of the brines, I use here a slide that I like a lot, a definition, and it comes from WSSTP, now it's Water Europe, where Loïc also is working for, and it dates back to February 2012. They had said that brine can be defined as water which has nearly reached saturation point with dissolved salt, so more than 50 grams per liter, and usually, but not exclusively, sodium chloride. And then below 50 grams per liter, they just say about the industrial wastewater, the brackish water between 0.5 and 30 grams per liter, and saline water from 30 to 50. And above 50, it is a brine. This is a definition coming from Water Europe back in 2012. And from the same publication, they said about the brine emissions in Europe. And what they stated is that publicly available information for brine emissions from specific industrial sectors is limited. And the case is still the same. It has not changed since 2012. And what they did, and I will show some results later on from my research, is that the predominant salt discharge is chloride. So it was used as a proxy to map the brine emissions. And I did that also in the Zero Brine project. This is a project, Horizon 2020, that has been completed, and I will show you some of the results for the origin of brines. And how did I did my research? I used the European Pollutant Release and Transfer Register, the EPRTR, which covers 28,000 industrial facilities from 65 economic activities and 91 pollutants. And one of those pollutants is from the inorganic group, and that is the chloride releases, as we discussed from Water Europe publication. So here, from 2018, one of my publications, I just mapped and quantified how many facilities in Europe are emitting chloride releases, 17 million tons per year. And you can see, where does this brine come from? From chemical industry mostly, which is with blue, followed by waste management, mineral industry, energy industry, and then the others, which you can see with a bar on the right, from the pie, it is production of metals, production of paper, animal and vegetable products. And what I did is that then I went one step further to see that in the Netherlands, because we have a very nice register there, which is called emissieregistratie. And then I mapped all these brine effluents, 277 facilities, 870 kilotons of chlorides per year. Apart from the mapping, let's see, what do we learn from that? Here are the four main sectors that for the Netherlands now. Chemical industry is again by 61% the biggest, followed by salt mining industry, 29%. But the interesting part for the chemical industry is something that you will see also in one of my next slides. Here is for NATS 2 region, I think, illustration in the Netherlands. Where do you have the chemical industries? And 54 facilities with, you can see the chloride releases here. Now, what I did is that after Zero Brine, we had a brine recycling in the chemical industry project that you will see in the second part of my presentation. So what are the different technical approaches to brine valorization now? I will structure that within this project that is currently ongoing. It is a Horizon 2020 project called Water Mining. The title is Next Generation Water Smart Management Systems, Large-Scale Demonstrations for a Circular Economy Society. It's a large project of 19 million euro involving 38 partners from 12 countries, and we are coordinating that with the TU Delft. Now, the concept is that we see water throughout the value chain, so either as a resource or as a product, and if a product is a consumable or a durable goods. And we have established 3 lines of research and demonstration. Seawater desalination brines is the sea mining, urban wastewater is the urban mining, and then industrial wastewater is the industrial mining. And I'm going to give you now the examples of the technologies from the sea mining and the industrial mining group. Starting from the sea mining, here is a demonstration that we have done in Lampedusa Island. Lampedusa is a small island below Sicily in Italy, and here is the technology, the treatment train. So we have multiple technologies, as you can see, to recover those resources from the seawater desalination brine, and I will just guide you through now. We start with double pass nanofiltration, and what we do, this is a technology supplied by Lentech, that's SME. We separate the brine into a permeate and retentate stream, and I will just discuss both now. Starting with a retentate, with a brine coming from the nanofiltration, we have the multiple feed plug flow reactor. It's a technology patented by the University of Palermo, and they recover magnesium hydroxide with 99% purity and calcium hydroxide. Now, downstream, we have the eutectic freeze crystallization, which is a technology developed by us at TU Delft, and we are recovering sodium sulfate. And further downstream, we have the electrodialysis by polar membranes, where we recover hydrochloric and caustic soda. Now, in our case, we just use that internally, but you can just also use it externally. Now, if we go to the upper part, in the permeate, we have the high pressure nanofiltration and the multiple effect distillation, which you can use one or the other, depending if you want waste heat or electricity to drive the processes. And downstream, we have the evaporation ponds or another crystallizer. So you can see here the complete treatment train that we have already demonstrated in water mining. You can see that this is pre-industrial scale, so it's not a low TRL, but it's 7, 8 already. And I will just now move to the industrial mining cases. We have in the chlorine sector in the Netherlands now the application. You can see here a map of Rotterdam Port where the chlorine sector is focusing. So Nobian is the company that produces the chlorine, and they have 3 chlorine users downstream. One of them being, you see here, Hexion, now it's called Westlake Epoxy. And what we do is that we have a full circularity, so we purify the stream and we get it back to Nobian. The impact reduction by 30% of water consumption, energy consumption reduction 25 megawatt hours, and of course kilotons of CO2 are indirectly saved. Full circularity, we have circular economy business model innovation through chemical easing and no discharge. Now, this is how it looks like. So Nobian in the value chain holds also the salt production and the chlorine production, and downstream is Westlake Epoxy. And what we do is that we purify the brine and we take it back to Nobian. And the TRL is 7. I'm not really allowed to give a lot of details about the technologies, but maybe we can discuss this if there is any question in the Q&A. What are the economic drivers for brine valorization now? My last part of the presentation. Recovery of secondary raw materials, which in certain cases, or in many cases, can be the main product recovered, with water being a byproduct. And I don't mean that in terms of volume or mass, but in terms of value that you can capture. Reduction of environmental fees. Sometimes there are cases that they're paying a lot of fees, and this can be a driver to adopt a circular economy solution. Creation of new business opportunity. What do I mean here is that there are industries that want to expand their production capacity, but they're being limited by the effluent limits. And we had such a case study in Zero Brine project. And then establishing local value and supply chains, safeguarding access to raw materials. And this is also very relevant for us in water mining. We have in islands where they are sourcing chemicals or other materials outside their territory. They had experienced disruption of the supply chains affecting the economic activities. So that could be a very nice way from seawater to get these materials from. Conclusions. Brines can originate from industrial processes as well as from seawater desalination plants. Now, for the industrial processes, chloride releases can be used as a proxy to get some insights per sector. And we can do that by using the emission registers. I showed to you how you can use the EPRTR or emission registratie for us in the Netherlands. But still, information on industrial brine emissions is limited. A considerable amount of projects is focusing on recovering resources from brines. For example, I showed to you the Zero Brine and the water mining project. Of course, Waste2Coag is another one. Over the past years, reflecting also the call for enabling a circular water economy. So that was my presentation. Thank you very much for your attention. I want to stop sharing. Okay.
Okay.
Am I in time, Blanca?
Yes. Thanks. Okay, thanks a lot for the very enlightening presentation. And yes, you were spot on with the time. So thanks a lot. Our next speaker is going to be Loic. So please, Loic, if you can upload your presentation.
Yes.
And turn on your camera. Yes, so we can see you now. And yeah, and it has been mentioned in the chat. If you could remove the hide note at the bottom of your slide, that would be very helpful. Yeah.
Yep.
Perfect. Thank you. The floor is yours, Loic.
Perfect. So thank you for the invitation. I will start to present quickly Water Europe. Water Europe is a recognized voice and promoter of water-related innovation in Europe. So we gather 260 members now from 32 countries, and we gather the full value chain of the water sector, like multinational cooperation, utility research centers, but also large water industry user like Coca-Cola or solution providers and SMEs. We have two specificity for the European landscape. The first one, we are a purpose-driven multi-stakeholder association. As I just explained, we have this the full value chain public and private solution provider, but challenge owners. And the second one is we are a value-based organization. So we have developed in 2014 a vision called the Water Smart Society. And when we advocate who promote collaboration, it's always when member interests meet with this vision. So to the next slide to explain you a little bit what is the vision. So the Water Smart Society is a concept that we initiated some years ago now, and we just updated in March 23 during the UN Water Conference the concept to really put at the center the value of water. You have three main objectives, which is to achieve water resilience, security, and sustainability. And to do that, we identify 5 areas of investment and innovation. Of course, circular water, so it's to close the loop, the water loops, to multiple waters, so to diversify the different sources of water, including reuse water and capture water, which is important in the context of brine management, digital water, but also inclusive governance, and resilience water, so mainly for infrastructure. So you can see on the slide the definition. It's slightly different from the previous one, but mainly to integrate the demographic change and climate impact, but also to really put the value of water at the heart of these definitions. So now when we enter more in the political landscape of the political activities in Water Europe, when we advocate, we base our activities on the vision. It's part of our societal responsibility, but we try also to be evidence-based and technological neutral. And here we have several projects entering in this process to provide inputs, but also we check that it's financially and economically sustainable, so that we have the outcome of the project, but also a double check internally by the different segments. And if we speak about Brine is a little bit everywhere, as Dimitri showcased in his presentation before. You have Brine in textile, coal industry, chemical industry also, but also for drinking water productions. And you have, in fact, several legislation touching these points. So, for example, the Industrial Emission Directive, taxonomy for financial aspects, the Circular Economy Action Plan, but also you can follow up on the implementation of this legislation through the different European expert group. So you have one mainly generally for each key legislation, like the Industrial Emission Directive, the Drinking Water Directive, and you have some specific platform like the Zero Pollution Stakeholder Platform. Here I will just zoom into legislations to give you some insight and go beyond the classical path. The first one is about the soil monitoring law that the legislative proposal was just released last week by the European Commission, and the strategy also, where they mention, for example, the restoration of soil in Europe. So here you do not have binding objective, but more an objective to monitor and report contaminated sites across Europe. And one of them that they target is salinized soil across Europe. So it's really important here to follow this type of political development or legislative development, because it can have an impact on brine disposal and management. They also make the link in the strategy with the Industrial Emission Directive. I will come back to that a little bit later, and also all the different research and innovation program, which are really important as an input for the legislation. So Dimitri was mentioning zero brine, water mining, for example. This type of project provide to the European Commission inputs and political recommendations that the EU institution will take into consideration when they are developing legislations. And here, allow me to touch a little bit about the Industrial Emission Directive and one good practice that we had with zero brine. So this project now it's closed, but the provided political recommendation, and at this moment, the BREF document for the textile industry was under revision, and we were able to include the outcome of the project in the document for best available techniques. And here it has an impact after on the deployment in of the technology across Europe. But also, if we turn a little bit the prism on that, you have an interest also when you touch the current barriers or opportunities. Dimitri was presenting the economic opportunities or drivers. You have another one, it's the administrative burden that you can have when you emit emission into water. In some country, you have a quantity allowed, and if you need to increase this quantity, you need to request new administrative authorization, and it costs time, it costs money for the companies. So investing in technology or resource recovery, it can help a lot. Also, you have another challenge. It might be a driver, and at the same time a barrier. It's the Energy Efficiency Directive. This one was just recasted by the European Commissions, and here they push for all the industry to be carbon neutral and energy efficient. So you really need to consider that this aspect, and I'm here considering, for example, the desalinization processes, which is highly intensive in terms of energy, and it can impact, in fact, the deployment of such technology. On the other side, you have the reuse regulation for agricultural purposes that can be an incentive to desalinization in some region, to provide drinking water through desalinization for their household area, and then reuse this water after for agricultural purposes, for example. And the last point that I would like to say is a little bit bigger here. It's the next Commission program. We have the election coming up in June. We are already working in Brussels on the next program of the European Commission. We have some element that resource recovery, strategic autonomy are key wording in this context, and the different processes and technologies that are linked to Brine's management are considering resource recovery. And that might be a new hook, a new opportunity for investment, or to unlock new opportunities for business or technology. I will skip this slide because Dimitri did a very good job, so I don't need to go too much on this example, and you know far more better than me. But you asked me what is the best option for Brine to prepare this presentation, and I will conclude a little bit here with an article done by a professor during the University of Las Palmas de Gran Canaria. He explained that in fact the most important is to have a strategic approach for brine management, and I do agree here that water related topics are really fragmented in Europe, and the solution needs to be adapted to the local situations. And it's why it's important to have water-oriented living lab, for example, but also the important to maintain technology neutrality in the legislations. You cannot push for one best technology, in fact, because sometimes the best technology will be different from one region to another, from the north and the south. And if you check the 7 parameters that it put for a strategic approach with brine management, and particularly in Las Canarias or in island regions, you see the red boxes are touching several legislations. So circular economy, you have the circular economy action plan, you have also the resource recovery action plan that is coming up. Reducing CO2, you have the Energy Efficiency Directive, the Industrial Emission Directive, and the two first one, you have all the maritime dossier coming from DG Mare. And above all, you have, of course, the Water Framework Directive or the Urban Wastewater Treatment Directive also. So all these type of legislation are really important. The legislative landscape is also fragmented, but it can open new opportunity. But I will say that the most important is really to remain technological neutral and to have the full picture when you start to discuss about brine management and disposal. And I think I'm also good with the timing.
Yes, Loic, you were also spot on. Thank you very much for your time management, also for providing this digested overview of the current policies in Europe, which is always really useful for us to see. I take the key message from you to looking at more appropriate technologies rather than the best technologies. There's not a best technology that is going to fit all. Totally agree with that. Okay, so our next speaker and final speaker is going to be Feliu. So Feliu is going to provide us an overview and the highlights of the work we are doing at LIFE Waste2Coag from the coordinator perspective. Thank you. Your slides are already on the screen. The floor is yours, Feliu.
Okay. Hello, good afternoon to everyone. Welcome to this meeting. I'm going to start with the context of why we are doing LIFE Waste2Coag, the problem to solve, which our previous speaker already pointed out, and the previous research and development projects, which were the seed of this one. Okay, to continue with the overview and the current status of LIFE Waste2Coag project. Finally, we will outline the transferability and what we want to achieve after the project. Okay. Well, the problem to solve is there is a high coagulant consumption worldwide with a value of over $7 million per year, with 70% application in urban wastewater treatment plants, but also a high application in industrial wastewater treatment, with a continuous price increments and which require also outsourcing outside the wastewater treatment plants. This coagulant consumption is expected to increase over the coming years, also related to the more stringent effluent concentration in wastewater treatment, especially regarding phosphorus content. Regarding brine disposals, Dimitris already gave some numbers, and indeed only from the desalination plants there are 142 million cubic meters per day, with 80% of the production and release of these brines are below 10 kilometers from saline water bodies. But 15% of this brine disposal is 50 kilometers away from saline water bodies, especially in countries like China, the United States, and Spain. There is, as mentioned, a growing trend in valorization because these brines pose an environmental problem, and normally, although not on a high level, there are land applications and irrigation of salt-tolerant crops, saline aquaculture, or farming of tolerant species. Also, restoration of saltwater habitats and energy generation by solar gradient pumps, as well as industrial uses as feedstock. So there is an increasing concern on increasing the sustainability of brine disposal, being research and development a hot topic, as we have seen. So to point to the concept of our previous research and development projects is the valorization of brines and metal wastes into coagulants to be used in wastewater treatment, either urban and industrial, using an electrolytical technology. These previous works were carried out by Global Omnium together with IDIME, which is also a partner of LIFE Waste2Coag, and imply laboratory reactor from 1 liter and also a pilot scale reactor, scaling up the previous results of 100 liter capacity. Just to mention the electrolysis, the concept is to apply a continuous electrical current to 2 metal electrodes immersed in a solution to cause a non-spontaneous chemical change. If we use an anode, an electrode of steel, we will be producing a iron-based coagulant, which is a substitute of commercial chloric iron chloride. iron salts. And also, if we use an aluminum electrode, we will substitute the commercial pack using an aluminum-based coagulant. What we do using brines is taking into profit the higher conductivity, which allows to apply lower voltages. So then we will end up with a lower electrical consumption than if we use other type of solutions. Some previous results, we seek and selected several suppliers of metal waste and also selected different metal wastes as an alternative to commercial electrodes, as we see here in the below image. Also, we characterize different brines from drinking water facilities, as global omnium is implemented in integral water cycles. So we also operate drinking water facilities. And we treated these metal wastes and brines at a laboratory scale in IDME's facility with the reactor that we see in this picture. Finally, after the previous results at the lab scale, we designed, constructed, and operated a 100-liter pilot plant unit, which we see in this picture, which was installed in a wastewater treatment facility in Canet. And the results that we obtained regarding metal concentrations is that we were evaluating the metal concentration with respect to the electrolysis time that we see in these two graphs for iron-based coagulants on the left and aluminum-based on the right. And we applied different current densities together with electrolysis time, reaching the higher concentrations, obviously, at higher at electrolysis time of 60 minutes for iron, although the optimum value we identified that it was at lower concentration because it was not exponential. And in the below graphs, we see the energy consumption per kilogram of metal for iron and aluminum-based coagulants for the two different types of brines that we treated, where we see that, as expected, the lower energy consumption was obtained for the brines with higher conductivity, 11 millisieverts per centimeter. We tested these coagulants in jar test applications and jar tests, and we observed how, as a tertiary treatment, we decreased for both types of coagulants significantly the phosphorus content in the treated wastewater from around 2 ppm to a value of 0.5 milligrams phosphorus per liter for the higher dose of either iron or aluminum here on the right. So with these good results, we decided to scale up this concept in this, where it came, the LIFE Waste2Coag proposal, which was awarded and started in October 2021 with the partners, as mentioned before, IDME, Technical Institute, Joviar, which is a small-medium company of the metal sector, IL Utilities, which is organizing this webinar, and also the water utilities, Aquafin in Belgium, and Global Omnium Medio Ambiente. The overview and current status of the project started with the obtention of the administrative permits, the design, construction, and commissioning of the prototype. Now we are currently in the optimization of the prototype operation with the coagulant production based on treating different brines and applying different conditions. And also we are expecting, once we finish to produce the coagulants at the optimized operational conditions, to apply them during jar test. And finally, once the system is optimized, to validate the coagulants in a urban wastewater treatment plant in Gandia, here in Spain, replicate the system by sending the technology to Wulpen in Belgium, and also operate the plant in an industrial wastewater treatment plant in Joviar, which is the industrial partner. IL is leading the market access and exploitation of results, and then the actions are completed by the environmental and and socioeconomical assessments, dissemination and communication activities, and also the monitoring of the impact of the project's actions and the coordination of the project itself. Here we have a picture of the constructed pilot plant and also the human-machine interface, and a short video with the commissioning of the installation. We just started to operate this month of June. And as mentioned, it will be installed in 3 sites. The first one is Gandia, which is a urban wastewater treatment plant located next to the Serpis River. Now it's not discharging to the river, but it's expected in the future to be an option, as it happened in the past, where we will expect lower limits on phosphorus emission. This wastewater treatment plant receives brine from 3 industrial companies, which are value of around 25 cubic meters per week, brines with different conductivity values, and from cleaning, textile, and disinfection products companies. Later on, in Wulpen, in Belgium, we will install the plant in this wastewater treatment facility, which is indeed located next to a drinking water facility, but by saying next is 10 meters away, which discharges around 14,000 cubic meters brines per week to the North Sea without valorizing them. Brines with a lower conductivity than the industrial ones we receive in Gandia. And finally, Joviar is generating brine for the production process with a smaller amount of 1.5 cubic meters brines per week, but with a high conductivity value. The initial results, we checked the purity of the scrap metals used as electrodes, as we see in these pictures, where we saw that the metal wastes contain a high purity of both aluminum and iron, indeed sometimes higher than commercial electrodes. And the first results that we have, comparing to the previous one on the left, we have the ones on the right. We apply in different current densities. We are increasing the metal concentration from previous projects. We are reaching values around 1,000 milligrams of aluminum, which was one of the objectives, to try to valorize as much as possible every cubic meter of brine into a coagulant. And also, because of the high conductivity, around 40 millisieverts per centimeter of the brines treated, we are also decreasing the energy consumption per kilogram of aluminum. Just to mention that these are values of the applied current into the rectifier, into the electrolytic reactor. So, as said, currently the previous results are being optimized and with lower energy consumption than obtained previously. And what we are looking for to test different type of brine, process them in the demo plant. We also looking to apply the alternative coagulants that we will be producing, treating different wastewaters. And for that, we look for networking with different stakeholders, and we take profit also of this webinar to encourage all of you to contact us via email, this address, our webpage, or via our social networks. Finally, as conclusions, brines and metal wastes has been correctly valorized from previous projects and scale up as the electrolytic reactor to this 1,000 cubic meter reactor that we are running in LIFE Waste2Coag. And next steps is to scale up the coagulant application to be tested after the jar test experiments, and we look for networking with stakeholders, as I just mentioned. And finally, just as a nice picture, we are also having visitors in our electrolytic pilot plant, as we see with this, I don't remember now the name, the Snapdragon, I think it was. And with this, thank you for your attention, and I'm open to any questions that you might have.
Okay, thank you, Feliu, and thank you for the photo of the new partner in the project.
You're welcome.
it shows that the system really is environmentally friendly. It is great. Okay, yeah, Chris, thank you. Damsel fly. So this is the name. Thank you, Chris. So then we are going to move into the next stage of this webinar, and we'll start with a session of questions and answers. We are doing really well with the time. So what we are going to do is we are going to go one round with one question for each one of the speakers, selecting for the questions that have been asked. And then if we have time, we'll go on the second round. So please, Eleonora, if you want to start.
Good morning, everyone. Thank you, Blanca. Yeah, we can start with a question for Feliu, maybe. So from Chris, what would be the cost of the coagulants produced with our technology compared to the conventional ones, you know?
Exactly. Well, that's we tested in previous projects that for aluminum-based coagulants, that was competitive respect to PAC, which has a higher price than iron-based commercial coagulants. In this project, that's an objective of the LIFE Waste2Coag, because we have to scale up also the production of the coagulants and take into account also the manufacturing process of the electrolytic reactor. So that's a point to be evaluated. And also inside the project, what we want to do is to compare commercial coagulants with our Waste2Coag, because we have a mix of species of iron, which we expect that we can improve that we can treat the wastewater at different doses that the commercial coagulants. And also we have versatility in the type of coagulant produced, because we can mix aluminum and iron salts to see which is the performance of this new mixture. So at the end of the project, we expect to have results, because indeed one of the objectives is to be more competitive than commercial coagulants. Yeah.
Thank you, Feliu. Moving on to Dimitris. We were wondering, you know, you have highlighted a few projects with a focus on brines, and you mentioned a few technologies with high TRLs. So we're wondering, do you know what's next for this technology? Have you seen a market upside for these, or are you also looking for a global market? So what is the next plan for this?
Thanks, Eleonora, for the question. Yes. And definitely in water mining, we are looking into that, because water mining is an innovation action, which means that it is targeting the market. And we are also focusing a lot on the social embedding. So we are looking in close collaboration with stakeholders and communities of practice, as we have named that in the project, how we can really select technologies that can provide what they need according to their objectives and interests locally. As a case, I could mention Cyprus. We had a workshop in last May, and we discussed, okay, you have this sea mining concept with 7 or 8 technologies that you have demonstrated in Lampedusa, but then what is applicable there locally? And what we did is that we looked in the different supply and value chains, the different salts, the different chemicals, and then we realized that not all of these salts and chemicals are relevant for this economy. So then we said, okay, out of these technologies, of the 8, then the 3 of them are really applicable. And then we looked into specifically what are the market specifications and quantities that they need locally. Because if you just go for zero liquid discharge in seawater desalination brines, you get mountains of salts and chemicals. And for the local economy, that is not useful, of course. So there are a couple of examples that we looked into, and mostly caustics and acids are really nice for them, because they have different market applications. So we looked into that with the stakeholders, and then we selected some technologies for that. Electrodialysis bipolar could be an example for that.
Perfect, very clear, thank you. Loic?
Yes.
There you are. So we wanted to ask you if you know what is the best way, in your opinion, that, for example, a project like Waste2Coag can inform policy making, particularly following your comments about the fact that the next EEC program and the Water Europe are already working on it. So what is the best way to inform policy according to you?
It's a big question. The legislative, not the legislative, the political process right now is quite complex for the next program, because in fact all the member states can provide input, but also the European Commission, the Parliament, the European political group, but the national political group also. So a project like Waste2Coag, it's to go directly, I think, to its local policymaker or the MEPs that are really important on this topic right now. And the most important is to come with short policy brief. That is really, really important. We see some policy brief from the project where more than 4 pages is far too much for a policymaker. It's very good for the European Commission, but it's completely useless for a member of the Parliament. And you really need to connect with the key topic or the hot topic that they have right now. So, for example, the strategic autonomy, resource recovery, the energy crisis. This summer we will have the water issue. So, in one way, it's very good for us to make the connection with that and to communicate at the right time in a simple way. Normally, it should work well. But for the next program, it's quite complex because you have a lot of stakeholders. And it's more than a full-time job.
Thank you. Feliu, going back to you. We were wondering, so how can the LIFE Waste2Coag solution affect the current scenario for brine management? So what do you think the solution can have an impact on brine management?
Well, thanks. Yes, I think it can impact, indeed, depending as Dimitri mentioned, every solution has to be adapted to every case. But currently, the waste disposal of brines might affect to the number of wastewater treatment plants that can receive these wastes. Okay, with the good point that they are not discharged directly to the sea, as in some facilities is made now, with a high concentration, because it's a fast release. With LIFE Waste2Coag, we will convert that into brines, into coagulants, but like we will homogenize it, will not be a peak release of brines. So more wastewater treatment plants maybe can get permits to receive and treat brines. And also industrial recycles with industrial wastewater treatment plants, they can receive the brines, which I think sometimes they do now, but they are not valorized indeed. So I think that could change the way brines could be managed, especially for decentralized wastewater treatment plants, which might be close to industrial areas with brine management for industrial processes. Yeah.
Thank you, Feliu. For Dimitris, we also have a question from Wilfred on the chat, and he was asking about energy reduction in your technology. So yes, with a comment, I expect that from raw material into Nobian to waste at the waste lake, the energy reduces, but entropy increases. So recovering that could cost energy. What do you think?
Thanks for the question. So this is, of course, per case study, and it differs. But if we take the example of Nobian and Westlake, what happens is that you get the salt through solution mining in the northern part of the Netherlands. I think it is called Delfzijl, the area there. And then you have to put water underground, and then you have to get a solution out. You have to put energy to make it at a solid form. You transport that then in the southern part. Then you dilute again with water. So all this water coming in and out, and you're removing by energy input that is not really necessary for the process downstream. So what we do now is that you get in the same neighborhood, because chlorine is no longer possible to transport in the Netherlands because of a law. In the neighborhood, you have the chlorine producer and the chlorine consumer. And the chlorine consumer, the chlorine use stream, is at a nice concentration level, let's say, around, I think, 12% or so, TDS. So then we just use waste heat, first of all, and we make it exactly at the concentration level that they need after you purify from organics to get it back to 20% then, TDS. So that you can save, this part you can save because you do that locally there. And of course, you have the energy of transportation that you no longer need that because it is the northern part and then it is the southern part of the Netherlands as well.
Thank you, Dimitris. I think we have a time for one short question, maybe to Feliu. And what, if you know, can you treat different type of brines in this type of technology with the LIFE Waste2Coag solution? Have you tested different type of brines? What are your plans for this?
Yes, indeed, we in Gandia are receiving 3 different types of brines. In previous projects, we tested 2 different types. And as far as it's a brine suitable to be discharged, especially in wastewater treatment plants, especially avoiding toxic metal content. So that would not, we will not foresee any problem, because what we want is the metal from the electrode itself. The brine is the medium to release the metal and avoid a high energy consumption, which in an industrial scale would be provided by solar energy. That's the objective, to monitor the energy consumption very closely and design a renewable energy system to fit the prototype.
Thank you, Feliu.
Okay, so with this, I think that we are going to close the question and answer session. Thank you very much for all the questions being asked and your responses, Feliu, Dimitris, and Loic. From my point, I always like to think about what is the take-home message that after I listen to any webinar. So I'm sure that for each one of you on the audience, you'll have a different key message that you are taking home. I'm going to share with you the ones I'm picking up and see if there is any overlap with what you take. So for me, it is the added value of the project is clear, using an innovative approach to produce coagulants. There is a new market opportunity, so more wastewater treatment plants in Europe and possibly globally will be able to manage brines in a different way. There is no best technology solution, and this has been, I think, highlighted by the 3 speakers, that fits all. And what we need is to identify what is appropriate and maybe to adapt it to the local needs. And finally, something which is very important, particularly for the activities we develop within the project, is that it seems that there is a market for this type of solutions. It seems that there is an appetite, particularly looking at the aspects of resource recovery, not only looking at the brine, but also the water, as it has been highlighted, even if the focus was the brine. But we need to consider the global picture. We need to look at the barriers and also the enablers. So policy making, sometimes we look at it as a barrier, but we have also to look at it as an enabler. And I'm taking with me homework that Loic has indicated. We have to think about how we best can engage with policy making. They need our input, and we need the barriers to be transformed into enablers. So we have to think about policy briefs, not only providing the technology merits of all the solutions that we produce. So this is my take-home message. As I said, I'm sure that many of you will have these similar or others, which would be great. So we have been collected a few questions. Maybe we didn't have answers to address all the questions. We are going to share the presentation through the channels that we have. So we'll use our social media. The recording of this presentation, you will see it available in a few days in our YouTube channel for the project, but also please keep following us on LinkedIn, Twitter, our webpage, and of course, email us with all the questions. You will have all the links in our webpage, and if you search for LIFE Waste2Coag, you will see that. So thank you very much all for your participation. We are spot on time, so I'm very pleased about that as well, because I know that you are all very busy. Thank you very much to our speakers. A big round of applause, digital ones and real ones. Lots of applauses. So I hope everybody has been really satisfied with the outcomes. Thanks a lot, and have a good rest of the day and a good week. Bye for now.
Thank you very much. Bye-bye.
Bye-bye.
Thank you. Bye.
LIFE Waste2Coag has received funding from the LIFE program of the European Union.